So as we look at this guy, oh boy, there's the pencil over
this
here.
is in the homework packet?
No, this one's from our notes, isn't it? Page 31?
Oh, yeah, you're right.
Yeah. You guys, the rule yesterday, let's back this up. Hey, Healed, how would I take the antiderivative of x to the 6th? X to the 7th over 7. And then we got to add a c to that. You guys, how do I be able to check if that really is the antiderivative? Is the derivative of this that? What would happen with this 7 if I tried to take the derivative of this? Yeah, wouldn't this thing come up front? And I'd get 7x to the 6th over 7. Is that what I started with? Yeah. What's the derivative of a constant?
Nothing.
Good. So that's how I can double check that I got my answer right. You guys, this only works. This power rule only works when I've got these things in the form of variable to an exponent and variable to an exponent. This is too confusing. Can I use some? I cannot do the power rule here. Why is it not all this stuff to the 3rd over 3? Why is it not a? Well, let's check. What would this derivative be? What would the derivative of this one be? It would be chain rule. That 3 would come out front. So we'd get 3 x squared plus 1 to the all over, right?
And then
Times 2x. Is that what I started with? No, we have an extra 2x, right? Because that inner wasn't just a derivative of 1. So that's why it's not a, but they want you to choose a. Guys, we'd have to do some algebra to get this in a form that we could take the antiderivative. No calculus needed. How could we think of x squared plus 1 squared? Write that out, people. X squared plus 1 times x squared plus 1. Let's throw some parenthesis, an integral in front of that because we haven't evaluated that yet. No calculus yet. What would x squared plus 1 times x squared plus 1 get me? X to the 4th plus 2x squared, because 1x squared plus 1x squared, plus 1. Now can I go practice that rule that we just learned yesterday? Now Healed is ready to do it. Now what's the antiderivative of x to the 4th? X to the blank over blank. X to the 5th over 5. You're thinking of 4 because you're used to taking a derivative. X to the 5th over 5, I'm digging that. 2x to the blank over blank.
2x to the 3rd over 3.
2x to the 3 over 3. Antiderivative of 1. X, because the derivative of x is 1. Don't forget that c. So you guys, 6-9 is the last unit of chapter 6. We will have a test next Friday. So we'll continue 6-9 on Monday. Block day we will review. Thursday we will have a group test. Friday we'll have a test. You guys, you agree that a derivative and an antiderivative cancel out?
Yeah.
Where did this b come from?
The upper bound.
Upper bound. Where does a come from? So you guys, our motto literally from here to the end of the year is upper minus lower. It is what we're going to get that tattooed. We're going to basically have sleeves. Our thighs are going to be covered in tattoos. We got lots of tattoo on ourselves, okay? We got upper minus lower. Maybe you just throw bounds in there. The reason why I didn't write upper bounds minus lower bounds because our mantra, that word bounds might change along the way, but upper minus lower is going to stay. Okay, you guys, the difference of what we did yesterday versus today. Yesterday we had no bounds. Today we're going to have bounds. We got this. Let's just think about this. What's the antiderivative of negative cosine? Another way to think about it. Whose derivative is negative cosine? Negative sign. And are we going to mess up those negatives? Sure. It's going to be negative sign. And then I'm going to show you this new thing because yesterday we just said plus c. What we are dealing with now is we're looking for an area from 0 to pi over 3. This is what I call that evaluation bar. We've seen this before. This is letting us know lower bound and upper bound. I didn't use any of that until I was in college, any of that notation. But let me show you something. This is referring to the area from 0 to pi over 3. I can do second calculate. Look at option 7. Doesn't that have an integral sign? You don't have to do this. And I'd say from 0 to pi over 3. Oh, it didn't do it. It didn't do it. So negative 0.866 is what the calculator says. what do? We're just going to go with our mantra, and we're going to say, oh, I'm going to plug in upper minus lower to that. Just like you said, we're going unit circle. So we'd have negative sign of pi over 3 is plugging in my upper bound. And then it's always minus the lower bounds. So minus negative sign of 0, which would just be plus sign of 0. Very good. You guys, if this was free response, we're done. But let's say it's multiple choice. Pi over 6, pi over 4, pi over 3. The sign there,
Oh, the sign.
the signy, the y coordinate is root 3 over 2. What about that? Negative root 3 over 2. What about 0 radians? The signy, that'd be the 0.10. Sign at 0 is 0. Final answer. Oh, thank you. Okay, let's practice. Let's practice. Again, we treat this like we have no bounds to begin. Let's just practice that rule. All right, healed. Antiderivative of 3x squared. Go. Antiderivative. To the over. Beautiful. Thank you. 3x to the third over 3. How might someone rewrite that? Just x to the third, right? Antiderivative of x. Hitler, you're up. Antiderivative of x.
X squared over 2.
Perfect. If I was Ms. Meister, I'd write it as 1/2 x squared. Makes no diff. The reason we don't say plus c today is because we're finding the actual area from 1 to 2. The reason we did yesterday is we had no bounds, and we were just saying, oh, the derivative of this is that. Here we've got some bounds. So you guys, we're going to evaluate this from 1 to 2. From 1 to 2. Let's do it, y'all. What about 2 cubed? What's that going to get us? 8. What about 2 squared, then times a half, or divided by 2? 2. What do I do then? Upper minus. Do I need a parenthesis? Stevie, mind your parentheses, right? I need a parenthesis. What's that going to get me? 1 plus 1/2. Guys, we're good. I'm going to change this one to make this a 1/2. Make this a 1/2. My bad. So what is the antiderivative of x to the 1/2? Add 1 to that exponent. 3/2. Dividing by 3/2 is the same as multiplying by 2/3. You could write it like that, or you could write it like this. Makes no diff. From 1 to 5. The reason I chose this is because AP does expect us to be able to do this. Let's change my bounds to 1 to 4. Let's change my bounds to 1 to 4. 1 to 9.
Oh, 9.
Yeah, let's make it a 9. 1 to 9. Thank you, 9. Okay, you're going to say, why does she want 9? When I go plug in a 9 there, you guys, that's 2/3 times 9 to the 3/2. I chose that because they ask this. How do we do 9 to the 3/2 without a calculator? Power over root. Do I really want to do 9 to the 3rd power? No. Certainly not. Could I do root 9? Yeah. What's the square root of 9?
3.
3 to the 3rd power. 27. So now 27 times 2/3.
18.
Nice. 27. Okay, honestly, if you just want to leave it as 27 times 2/3, I'm fine with that, but that would get me 18. I dig it. So that's plugging in my upper bound minus 1 to the 3/2. 1 to the 3rd power. Square rooted. 1 times 2/3. Beautiful. Final answer. I'm done. Don't care. Okay, if we didn't have a calculator, we'd have to say that we'd have 18 minus 2/3. We'd have to get them each to thirds.
Would we normally have?
You wouldn't have a calculator for this.
Okay, that was interesting.
Yeah. 18 times 3 is what I'd have to do.
We couldn't say it is 17 and 1/3.
Oh, yeah, that's one way, but they wouldn't do a mixed number as if. 8, 16, 24, that would get me 54. 54 thirds minus 2/3. 52 thirds. Braddock, could you have gotten there by saying 17 and 1/3? You could have gotten there, but but their answer would look like this. Our free response answer would look like that, right? Let's try that one more time. Here we are. Antiderivative of x to the third. Ooh, or 1/4 x to the fourth. I dig both of them. Antiderivative of 1. Love it. We're evaluating that from -1 to 3. -1 to 3. What's going to happen when I plug in that 3 up top? Because we always do upper. Nice. 3 to the fourth. One way to think about that, 3 times 3, we feel good about 3 squared is 9. Times 3 squared is 9. 9 times 9 gets me 81. So we'd have 81 fourths, right? Plus 3. Minus. -1 to the fourth. 1/4. Minus 1. Done. Test this out.
It's deep.
1997 was the year I got bangs. Do you see how small this forehead is? No room for bangs, guys. It was a bad year, okay? The reason I bring this up, bless you, I think that you'll be fine, but
Radix already lost.
what about this guy? Let's go, what's the antiderivative of x squared? Love it. Perfect. Whose derivative is negative sine? Nice. No, you're right. Cosine. Nice, Soph. So, when we had things like this, life was good. I've got something to a power rule. I could apply this cute little power rule. I know these antiderivatives. Look at this. Look at this. Are these quite as like power rule-y as those? It's not quite as basic, okay? So what we've got to do, it said, what happens if we need to integrate? We don't have an antiderivative rule because this is madness. And for this, they call this U substitution. And I don't know why we use the letter U, but I do kind of like it because I could be like, U, as opposed to, well, I don't know. So here's the deal. You guys, you agree that this is madness compared to what we've been doing. This is quite madness. I need you to pick U, which is a part of this problem, whose derivative is also in the problem. What do you think, Dicey?
X to the third plus x squared.
He's like, if I chose this to be my U, what's the derivative of x to the third?
3x squared plus.
Derivative of x squared? You agree that the derivative was in there. So you're like, okay, I'm going to make my U x cubed plus x squared. And maybe you write yourself a little note, pick a U if U's derivative is in, I'm going to write EQN for in the equation. That's my little shorthand. Hint, the U's are often exponents. The U, or you know what, we could, maybe we don't even write it that way. Maybe we write it like this. The U is often an exponent. The U is often under a square root. The U is often in parentheses. The U is often the inner. I like that. Here's what we got. What's the derivative of this U? We were looking for the derivative. What is that derivative?
3x squared.
Perfect. Here's the thing. Can we think about what would the derivative of U be with respect to X? U prime, another way to say it with respect.
X.
So close. Du dx. Okay. And you're like, that seems a little silly. I hear you. What I'm telling you, this U sub is going to be part of a differential equation in a bit. And this will be a free response question. And the first point is given to you of the 6 points typically of this problem that involves these is called separating the variables. Do you agree we got a U over here, we got some X's over here, and an X down here? How can I get the separate the variables so I only have U's here and X's there? How can I move this dx over? Multiply by it. She's like, well, it's on the denominator. Can't I just multiply by it? And if I did, I'd have 3x squared plus my 2x and a dx. You would get 1 point on our free response for doing this step because you separated the variables. Okay, we separated the variables. I've got all x's on one side and all my u's on the other. Here's where your mind's going to get a little rocked. This is madness, right? I need to rewrite this in a way with only u's and no x's so that I can take the antiderivative. I need to rewrite it in a little simpler form. And you're going to be down with this. Check this out. Do you agree 3x squared plus 2x dx is right here? What could I replace that with? Isn't that equal to a du? So I'm going to rewrite this equation. And instead of writing all of this highlighted stuff, I'm just going to rewrite that as du. Du is always like a formality. It's like my last name. It's not that big of a deal, but it's important. I mean, it needs to be there. I need to rewrite this stuff too. E to the what? E to the u, right? You guys, I need to have everything compensated for. He's like, okay, well, I got an e to the x cubed plus x squared. X cubed plus x squared is the same as u. Is that the same as e to the u? Is everything now in terms of u's? Do you know what the antiderivative of e to the u is? E, we love e, right? We know that that's just e to the u plus c, since I have no bounds. What was that u that we came up with? X squared plus x squared, x cubed plus x squared. I'm going to go substitute that back in as my final answer. My final answer is e to the x cubed plus an x squared plus c. And you're like, what did we literally just do? What we just did is we took the antiderivative of this thing. My question is, if we did this right, this derivative needs to get me what I started with. What's the derivative of e to the anything? E to the anything. What's the derivative of the anything? What's the derivative of a constant? Do we do it right? So this is a lot of steps, guys. This is why I'm just going to show it to us today. We aren't going to have homework on it. Then we'll grind it with it on Monday. Here's the deal. Could you have done that without U sub? Some people would be able to kind of undo that chain rule in your head. Great. We're going to get to a point that you can do that. This is what I thought was a good starter question. All right, so that was uncomfortable. We're going to do just a couple of these. We're going to get less uncomfortable every time, I promise. Okay, to Mr. Dice's point. What do we want my U to be in this one? Yeah, that U is often under the square root. It's often in the parentheses. Okay, so we're going to take that 5 plus 2x cubed. Picking a U is uncomfortable because, to your point, it's like not obvious sometimes. The derivative has to be in my problem. What's the derivative of 5?
0.
Good. What's the derivative of 2x cubed?
6x squared.
Okay. Derivative of U. Good job, you guys. Separate my variables, please. You guys, do I have a 6x squared dx in my original problem?
Probably.
Not quite, but do I have a x squared dx? Could I get rid of that 6? du over 6? I'm going to give you a hint, though. Instead of du over 6, throw that as a 1/6, and I'm going to show you why. 1/6 du, now do I have an x squared dx from my problem? We're getting there, people. You're already looking better because obviously you hadn't done it before. Okay, instead of writing x squared dx, I'm going to write 1/6 du. Greer, when you've got the 1/6, throw that in front of your integral sign and then throw that du at the end. Du is like my last name every time. That just replaced that 1/6 and the du, replace this part. What do I have left that I still need to write? I've got the square root of u. And now Nelson's like, dude, why are we even writing it as a square root? Isn't that just the same as to the 1/2? And I like that because I needed that power rule to take that antiderivative. So you guys, we just changed this madness to this, and I like that. Now it's in a form that we can take an antiderivative. You made it look easier. I'm like, well, getting there wasn't easy, okay? But we did it. Now we can take an antiderivative of this. Antiderivative u to the 1/2. Add 1 to that exponent. 1/2 plus 2/2 would get me 3/2. Divided by 3/2 is the same as multiplying by 2/3, right? My little 1/6, he chilling. He got to come down, people. He chilling.
Use.
Yeah, that du turns into my plus my constant.
Because we just took.
The antiderivative, you got it, girl. Now,
We done.
what's 1/6 times 2/3?
Probably 218.
Which is 1/9. Instead of u, what would I need to go put back in there?
5 plus 2.
To the plus c. How many people are like, oh my gosh, what do you mean? Again, like, what did you even just do? Let me tell you what we just did.
Root, yo.
We just made a root. My question is, if we got this right, this derivative must be that. What? Back it up. I'm not even going to look at that. Question. What would the derivative of this be? We haven't done that in a smidge. Derivative of this. Derivative of the outer. 3/2 times 1/9. I'll even write that out. 3/2 times 1/9. Leave the inner. Exponent would turn to the
Times.
1/2.
1/2 because we got to take 1 away.
And then 60.
Times the derivative of the inner. Derivative of a constant?
0.
Okay. Question. What's that going to get me? 3/18, which is 1/6. 5 plus 2x cubed to the 1/2 times 6x squared. Oh, I could.
X
What's-
squared root.
Yeah, true. What's happening with my 1/6 and my 6? You cool with canceling those out? Did I get what I started with?
Yes.
We did it. Isn't that crazy? I think it's too hard to undo chain rule that way without doing U sub. Could you do it? Sure. But would you have come up with this? I don't know. Okay. U sub helps us take an antiderivative of something that's too complicated. We were able to check, and the derivative of our answer got us what we started with, so we did it right. Let's do 20. Let's do 20. What do you want your U to be?
7x minus 6.
Okay, look at this. I didn't even give us any lines or anything. Look at you. You are spouting this off. This is good. The U is the thing in the parentheses off, and that inner, as Dicey said, du dx equals. Say it again, Sammy. 7. Derivative of 7x is 7, right? How many people are like, oh, now I got to separate my variables? Could we have done that in one step? Some people on Monday, I bet, would start jumping to that. Just du is 7 dx. Okay. Do I have 7 dx?
Yes.
Could I get 28 dx by doing something here?
Yes.
What would we do?
Multiply both sides by 4.
If I multiply both sides by 4, we'd have 4 du's equal what? Equals 28 dx. Now do I have 28 dx?
Yes.
Yeah, I need to go rewrite all of this stuff in terms of u. I got a 4 on the outside, Greer. We got a du as my last name, well said. Instead of, so wait, we just took care of 28 dx. Love it. We need all of this 7x minus 2 to the third compensated. How are we going to write that? U to the third. Guys, can we take an antiderivative of this? Good. What happens to this 4? He chilling. U to the 4th over 4 plus my c. Greer's saying, oh, since we brought that 4 down, he's gone, right? What was my u? And I got to raise that to what power? You're saying that's my antiderivative. You're exactly right. And why is it? What would the derivative of this get me? What's the derivative of the outer? The derivative of the outer would get me a 4. Leave the inner.
7x minus 2 times 7.
Derivative of the inner? 7.
So 28.
Is that what I started with? You know what I'm saying? It's a good way to check. Yeah, Dar. Guys, this one looks disgusting. Am I right? I want us to accordion this out. Is this the same? Could I say, hey, all that squished together is the same as, could I say 1 over x times what times what? 1 over x times 1 over ln of x, well said, Mr. Nels, times dx. Did I just take all that? It's like a sandwich that I decomposed. Is that what I started with? Yeah, I didn't change anything. Someone said, what do you want my u to be? She said, ln of x. And that's why we did this question, because it's like, really? Yeah, what's the derivative of natural log of x? Is that in my problem? That's why you're going to pick it, because the derivative of your u was 1 over x. So we're going to say du is 1 over x. Maybe we're separating that variable in one step. Maybe we're not. Maybe we're saying du dx was 1 over x, and then we're separating our variable. Whatever, my pets. Whatever works for you works for me. Whew. Can I rewrite everything? Ooh, this is a crazy one. This just gets crazier. You guys, we got to rewrite all this. What are we going to rewrite 1 over x dx with? Just a du. So we've got just a du. Be careful. Then what do we have?
You did the negative first.
Close. I'm going to write it as 1 over u. Here's why I'm going to leave it this way. Actually, okay, don't write this. I'm going to write what Dicey said. Don't write it. Guys, if we're here or here, they're the same thing, Dice. That antiderivative rule, what do I have to do to that exponent?
Add 1.
What is negative 1 plus 1?
0.
That would get me u to the 0 over 0. Can I divide by 0?
No.
That's why this antiderivative, we can't follow that rule. Whose derivative is 1 over u? Whose derivative is 1 over x? It's ln. Don't forget, yesterday, we came up with these absolute value bars. They were new. Whoo-wee! So, Dice, I'm actually glad that you said that, because when we would go do our rule here, you'd be like, oh, it didn't work. You know what I'm saying? And it's a good reminder, like, oh, yeah, it's going to be something different. Guys, we got to do that of the absolute value at the bottom. What are we going to replace that with?
Probably ln of x.
Give me one sec. Another ln of x. This u value was ln of x. So this is so gross. ln of absolute value of ln of x plus c. Well done, Stevie. That was nutty. That was twas nutty. You guys, we got 4 minutes now. Try this guy. Try this guy. See if you can finish it.
Bro, it's Friday.
Antiderivative, bro, you've been on your phone. You don't have I haven't had a calculator since November, so I'm going to have you do this. Did I just roast you on film? Yep. What's your u? X cubed plus 1.
Nate, get off your phone.
Du dx.
3x squared.
Ooh. Separate those variables. 3x squared dx. Is that in my problem?
Yes.
Whew. Whew.
What?
Du over.
Be really careful. How would I rewrite this? I agree that 3x squared dx is going to be a du.
Du over. The square root of u.
Where is that square root of u, though?
1 over the
It's 1 over that, isn't it? 1 over the square root of u?
Can't you
So
just
just be
put it
u.
over the square root of u? Does it have to be one next to it, or could you just put du?
I would keep them all separated. It's harder to see. Yeah. This is the same as u to the 1 over u to the half.
Yeah, sure.
I definitely would. We can't do this without it being in our good old power rule look. You got lots of room to the right there. You got lots of room to the right. You can use it.
I'm just writing obsessively.
Oh, I see. Add 1 to my exponent.
One half.
Dividing by my new exponent would get me a
2.
2.
Plus.
When you plug in your u,
Yep.
is that an answer?
Yep.
Yeah, it's probably a.
2 root u, and my u was an x cubed plus 1. Whoa.